So in a previous video, I had you guys graphing lines by making a table. And a table is a really good method to use, but this video is going to show you a shortcut that you probably already remember from Algebra 1. We're going to learn how to graph lines in something called slope-intercept form. And slope-intercept form is exactly what you see written on the board right here. It's your y equals mx plus b. The two pieces you have to know in this little formula right here are that the m, the number in front of your x, being multiplied with x, is going to represent your slope, and the b, or your constant, the plane number without a variable, is considered your y-intercepts. And if you know these two pieces of information, it's very fast and very easy to graph a line. I'm going to make up 3 examples in this video, and we're going to take a look at them here. My first one is going to be y equals negative 3 over 4 x plus 2. So when you graph a linear equation like this, you're going to first find your plane number, which in this case is the positive 2. That is going to be my y-intercept, which is where I put my first point along the y-axis. When you graph lines, your first point should always go on the y-axis. So it's positive 2. I would go and put a dot right there from this number. And this negative 3 over 4 is my slope. I'm going to count it out using rise over run from the dot I already have. So I would go down 1, 2, 3, because it's a negative 3, and the bottom is a positive 4, so I go right 4. I'm going to end up right there for my second point, down 3 over 4. And you can do more points, count down 3 over 4 again, but once you get a couple points right here, you just connect them with a line like this. So that would be my graph for y equals negative 3/4 x plus 2. I'm going to make up 2 more examples in this video. For our next one here, let's say my equation was y equals negative 5 plus 2x. In this problem, my equation was written backwards from what we're used to up here. Usually the x part goes first. You could rewrite this in the other order, but it's actually, I think, easy enough just to graph it as is. My plane number, the constant, is going to be the y-intercept, so I'm going to start my graph at negative 5. This is the number without the variable. I would go down to negative 5 on my y-axis, and my slope is a positive 2, or positive 2 over 1. So from my dot, I would count up 2 over 1. I'd get my second dot, and then I would keep going like that. I'm making my graph kind of small in here just so it fits on the screen and everything. But I would just keep going up 2 over 1, and then you draw the line. So it starts at negative 5. There's my y-intercept right there. Positive 2 over 1 is the slope, up 2 over 1. One last example for this video right here. And even though this line is arguably the simplest one, it's the one I find kids mess up on the most. Let's say I just had y equals x. It's no extra number over here. There's no numbers anywhere, really. It doesn't look very fancy, but kids mess this up more than they do the harder ones where you have actual numbers going on. So in this problem here, we're going to go ahead and put a 1 in front of this number. So we have a 1 for our slope, and we aren't adding anything. So that's like having a plus 0 over there. So I'm going to start at 0 on this problem, and my slope is a positive 1 over 1, up 1 over 1. I would get a second dot. I could keep going up 1 over 1, and I would connect these into a line. So I lied to you guys actually, accidentally. There is one more problem I want to do because it just popped in my head. I have not shown you what to do if your variable is not already by itself, if it's not in this form. So let's say I had, for example, 3x plus 2y equals negative 8. If this was my equation right here, it's not in slope-intercept form, I can't graph it right away. I have to get the y by itself, which you guys are probably pretty familiar with how to do. I would start out by subtracting 3x on both sides. I can rewrite this now, so it's going to be 2y equals a negative 3x, and then it's negative 8 after that. And then finally, I would just divide everything through by 2. So I'm going to get y equals negative 3 over 2x, and when you divide this out, it's going to be minus 4. So I would go down to negative 4, and I might be going a little bit off the screen right here. Let's see, negative down 3 over 2 would be a second dot, right there. It's just a little bit off the screen. What you can also do is reverse that. I'm going to go up 3, left 2 in the same pattern, so it actually fits on the screen right there. And then I can go ahead and just connect my points. So if you have an equation where y is not by itself, your first step is to isolate y and then graph your line.